Yes, hello everyone. Good evening. My name is Yulam Gadkos. So today we are here to talk about our module named Muse Chakula. So this module is basically source elder nutrition planning. So yeah, it deals with food like as in food as medicine for the elderly people in given regions of Uganda. That is that's north, central, east, and west. So our module is is able to detect like given this area is able to detect that this food is from given area or region, or this language is from given area or region, something like that. So let's go to introduction straight. Yeah, as we can see, the content of presentation. So the content of presentation, we have the introduction, that is the setting. This one deals with the setting of the stage for our research. We have problem statement. This defines the core computation challenge. We have research questions and objectives. This guides our investigation and goals. And research contributions. We have the system architecture, our approach to solving the problem. Data set description is the foundation for our AI module. Results, experimentation, we have simulation. These are key findings and their implications. There we shall talk more, or we shall conclude by summarizing our work and future directions and limitations, contradiction, plan, references, and acknowledgement. So let's move to the next step or next slide. So we already talked about the introduction and the background. As you can see from here, there's an image of a woman in rural area in Uganda. She has the diabetes and hypertension. So these are the people that our module deals with. So it deals with elderly people above 60 years. So this one, the module is supposed to interact with the caregiver to determine what kind of food as medicine. Of course, food is the one acting as medicine this time around. So what kind of food is supposed to be given to this elderly person, as you can see. So, and also like this local food, I think they are from the source and they are not malnutrition, something of that. So we can move to the next slide. So we have the related works and recent trends, as you can see. So the trends, we have knowledge graphs for reasoning. So this knowledge graph for reasoning is like, yeah, this is a module that is able to think like human beings, like the way human being can think. We have the light, we have the light language modules in healthcare. So this one is details AI that is able to think like human being also at the same time. So we have traditional nutritional modules. Existing modules often rely on generalized dietary guideline frequently overlooking regional food, diversity, and socio-economic realities in Africa context. So as we say, yeah, as we already mentioned, like the context is it's based on Uganda's regions, as we already mentioned the regions. So with time also it can move beyond Africa. Actually, Africans, like most regions, they have the similar traditions, like when it comes to food and other cultures. Move to the next one. Yeah, we have the problem statement. I think here my colleagues will come in and
Thank you
give you more
very much.
details about problem statements.
Thank you very much. I may talk about our problem statement, but also relating it to the computation statement. So Mother is an innovative AI that is going to handle, as my colleague has explained, the elder iteration. So what we did in our computation problem, since our agent is going to be a graph-based agent, AI agent, we did mapping of complex relationships. So how we collected our data is we collected the conditions, those are the diseases that are common in elders, then we related them to foods they can eat that fall within the diet under that disease. Then maybe we looked for nutrients that we can map to to those specific foods related to that disease. Then we also looked for drugs. So how these things are being are connecting to each other. We have conditions relating to foods, like if someone has this kind of condition, maybe ulcers or diabetes, what kind of foods are they supposed to eat? Then after connecting them together, after seeing the relation, we related the data set with food and nutrients. So here we are trying to see which kind of nutrients are qualified to be in this food. Like at what percentage is the elder supposed to take? Like let me say if someone maybe has diabetes, what quantity of sugar are they supposed to take? What percentage is supposed to be included in their diet? Then we have the relationship between the drugs and the nutrients. So this collaborates with how how elders have to take so much medicine. So this relationship explains how the food that they're taking is interacting with the drugs they're taking. So this AI bot through our training, like how we are going to train our how we trained our model is that it can be able to know that if this person is suffering from this, they're not supposed to eat this they're not supposed to eat this food when they're taking this kind of medicine. So in our data set we also have the types of medicine that fall under that condition, but not all of them, since we were still collecting the data set. This is like a pre-model, but as we fine-tune our model, we do believe after collecting enough data sets, we shall be able to deliver better. But for now, it is trained, and we're going to show you the analytics that came from our simple training. So here I'm going to just describe a few things of what we did. So our input is the data that I've explained. We have the conditions. Then yeah, we can just show you a number of what we have. We have 45 conditions. Then we have the nutrient to condition relationship. That's how the nutrients connect to what kind of okay, like which kind of nutrients are these people supposed to have. So we have 178 relationships. Then food to condition relationships. That is how the food is related to the certain disease they're having. Those are 177. Then medical features, that's like the medicine that falls under that specific disease. There are 65. Then you have food to drug interactions. That is how the food interacts with the specific drug the person is taking, suffering from that disease. Then we have the Ugandan food mapping. Now, since our agent is best for Ugandan elders, we have foods and we're categorizing them under regions. So different regions have different staple foods. So we make sure that if our agent is being asked a question, it can be able to track which region that person is in and which region they're asking from. So yes, from there we consider our computation agent. So our model is a supervised model. So when it is going to be trained on already labeled data. So that's what it means to be supervised. So as I've explained it here, it's just showing a couple of our features. Then we have the output. So the LLM tells you what to avoid, the limits that you're supposed to take, that is in quantities of the nutrients. Then we have the recommendations that come from the overall chart that you have with it. Then our objectives and constraints of our training, we have our accuracy was 65, which is quite low. As I explained, we had an issue with data collection that we are still trying to solve, but we are to deliver better in our second presentation. Then we have culture sensitivity, that is, like I said, staple foods, regional, medical safety, like how we are considering drug to food interaction. Then regional accessibility, that means central. Yeah, going to move on to the next slide. So here I'm going to tell you like the objectives of our research. So our first question, what we asked ourselves was how can we integrate knowledge graphs with LLMs to generate personalized nutrition recommendations for elderly patients in resource limited settings. So how we did this is I've already showed you in the other slide, like how we related our data sets. We made sure that each data set we are making is relating to the next data set. So this is how we summarized how the LLM is going to connect with our graph. Then the objectives were of course, to identify the common elderly diseases, to identify and validate what kinds of data sets we need to relate with each other to bring out the information we need for our model. Then of course we needed to know how food interacts with the drugs, how to so that our model can be able to understand how to explain well to the caregiver in a way a doctor would explain. So moving on to the next slide. So here I'm just showing you a basic architecture of our model. So here we'll start with the patient input, that is the caregiver. Let me say the caregiver is going to ask, I'm handling an elder. She's maybe suffering from ulcers, yeah. And these are the kinds of foods she has been eating overall. She's not feeling well and she has low appetite. What can I do? So now this person has given a brief record of that patient's background, but they can also upload. So our chatbot will also have a place where you can upload, so that the LLM, the large language model, can be able to process and answer according to the data that you've given it. So after it processing these patient records, we have the recommendation generation. Now, it after understanding the conditions of your patient. Of course, as we explained in our previous presentations, that LLMs don't think, but they just use the data that you've given them. So if you give it wrong information about the patient, it also give you wrong output. It is garbage in, garbage out. So we in our making, we shall make sure that the guidelines are clear for our caregivers so that they understand that if we give this agent wrong information, of course you will get wrong recommendations out of it. So after the model understanding and recommending, you can continue to fine tune your prompt. As you're refining, it's also improving its explanation of generation. Now this is the step of fine tuning. You give it feedback, it explains the generation. We forgot to give a back arrow here. There's supposed to be two arrows between these and these. So here we have food planner. So that's like the final output after you've finished explaining what your specific elder you're dealing with, like the problem you want to solve. The final thing will be a food planner. Of course, this is not like the final output. You can describe the format that you'd want your output in. This is just like a basic default output. Okay. So moving on to the relationships, so dataset description and explanatory data analysis. So here, I'm just going to give you an overview of what our analysis is going to show. So as I already explained, our relationships, each data set is connected to each other for a better graph-based reasoning. Then we have data completeness. Or okay, our data sets have the data is really less, but it does serve the purpose that it's supposed to serve. Then data quality, it's high quality because we connected it from recognized sources, that is who as my colleague will share later. So rich data set structure, that is showing you that at least you have over 675 total entries in all our interconnected datasets. So that is roughly enough to train a basic model. Then we have a relationship density of 2.7, which is okay. We have a comprehensive coverage of 45 times 65 medications. Also, these are just interactions of our extensive knowledge base. So this gives you, and here it's showing you have 60% of the foods that have high cultural significance. So this tells you that you have 60% of the regional foods in Uganda for each region. Okay, so moving on to our data analysis. So this was just to give you an overview. Now we are going to go and see our visualizations. Okay, so here we have elderly conditions. So here you can see cardiovascular, it's the highest. Like those are conditions of the heart, I'm presuming. Then we have infectious, we have nutritional, we have renal, we have metabolic, we have sensory. There's so many. So this gives us an overview of what conditions we have in our data set. Then here you come and see food categories that we have. So we have protein, vegetables, staple, those are foods that are categorized by the region. Then we have fruits, we have beverages, we have sweeteners, we have dairy, we have seasoning. So as you know, elders are not advised to eat very spicy food, but that doesn't mean the food can't be like seasoned. So there are those kind of seasoning that are specific for elders. So yeah, that's where seasoning comes in. So here in our pie chart, we are just showing how food and condition relate. So we see that 80% of our data is recommended for the specific conditions that it's related to. Then 1.1% is labeled as avoided. Like if you have this kind of disease, please avoid this kind of food. Then 14.8% of our data set has food that you have to limit if you're suffering from a certain condition. Then here we have results of medical categories. So here we are showing specific kinds of medicines that relate with our different conditions. So these are the medicines that we're able to collect from our different sources. But like I explained, we are still in the process of data collection, and we do promise to to have more data in our next presentation and be able to show you a better, I think, a broader analysis. Yes, with better visualizations. But for now, this is enough for a basic model. So these are just the different medications that we got for the different conditions that we have in our data set. Okay, so here we have food interactions. So this is just showing you how food now is interacting with the medications that you have seen in the other bar graph. So here we have altered absorption. That means if you take this food, does it affect how the body is going to absorb your medicine? Is it going to alter the medicine to be absorbed within the food and not like do its purpose? Then we have increased drug toxicity, sorry, that means that if you take this food and this drug and they combine together, it could become poison and it could just arise to another condition. Then we have nutrient depletion. That means that if like the drugs are connecting with the food, they're going to like dip remove the nutrients that your body would have gained from, and they consume them for themselves. Then we have reduced drug effectiveness. Some foods overcover the drug effects. So even though you have like pain, the painkiller won't work because the food already affected its effectiveness. So here, so that's food and drug interaction. Then here we are showing what kind of levels do we have with this kind of interaction. There is moderate, there is severe, there is mild. Now severe is like the high warning. Here the agent will tell you that, okay, if this food interacts with this that is severe, it could cause this and this. So I think this gives you a broader view of what we did and the relationships we considered for our data sets. Okay. So here, now that I've explained and showed you how our data sets are relating, here I'm showing you how our model was trained. So this is like a basic pipeline that our model followed. So we got the 25 features of our data set. Then we did data cleaning. That includes where we got the visualizations from. Now here we pre-processed it and we used the random forest model. Why did we use this? Because okay, according to our research, it will give us the best results, and it gives a balance. It balances. It's able to balance like the data you've given it. Yes, so from there we have a random forest algorithm being training our model. Then after that we get a recommendation and monitoring. Then from monitoring we get explanatory post-processing. So this is the architecture we followed for our model. First we followed there is input, then there is output, which is a recommendation. Okay, I'll let my colleague proceed.
So thank you once again. So we have reached to conclusions. So in conclusions, this is where we are going to talk about the limitations, the future trends, that what we are expecting our module to be doing in the next given years. So here, like the module, as we talked of, we say that the module based on regional and local cultured food. Yeah, as in the caregiver, as we said earlier, the caregiver is supposed to interact with this module so that to monitor the conditions, the kind of food, and the nutrients that are supposed to be taken in by the patient who is an elderly person like above 60 years. So that's what our module is going to be doing. And again, the limitations, yeah, the limited data size, but for future work will expand, as we say. Of course, it will depend on our users, those who will be using the caregivers. So will tell us more about this module. How effective is it working, and what is lacking, and what works best that need to be improved. So it will depend on on the person who is using this module, exactly the caregiver, to give us the best feedback so that we are able to predict the future, and also we are able to improve what is already there for them. To the next slide. Yeah, we can see a demonstration of the developed product. Yeah, here we assume that it is already developed, and you can see the patient. As you can see, the diagrams or the pictures, so they are demonstrating what this elder person does, or what the caregiver does to the elder person. As you can see from the beginning, let me say they have the wardrobe or wherever they have. So you can see their stuff there. Maybe you can see the things. Maybe they could be in for maybe the medicines they are there, all kind of food. You can see they are putting the plaster on the hands and kinda, and the woman is eating. So this one is a demonstration of the developed product. So here, like we are trying to see, so the system like trying to recommend a given food for the elder person, and trying also to tell that this person is supposed to avoid this kind of food, as we have already seen in the graph that was given. So as we said, that most of our module, okay, like our module mainly focuses on the recommendations of this kind of food to the elderly people, and we saw the percentage of the limitation or something to be avoided is very small. So, and since it is based on the regional or cultural food, that's why we are recommending mostly. So we move to the next slide. Yeah, the next steps or the futures or the future work pointers, as I've already talked about. So like we are trying to see that in future we can expand the data set to more foods or diseases or nutrient related to a given to a given kind of food that is supposed to be recommended to these elder people. So we are trying to expand, like in case we find out that yeah, it is really working. So this part is really working, or this kind of data set is really working. That's what we shall base on and improve. So there's also improved explainability with clinician, clinician feedback, or the person who is using this module. Therefore, yeah, we are trying to improve how we can explain basing on given to us by the you work in the hospital. That so shall we are trying to see how we can improve piloting or pilot with healthcare providers. So we are also trying to draw a way of putting it into use, or trying to make plans with the providers, those whom we are providing the healthcare, trying to see how to come up with this kind of module base and how we can improve it well. Next. So yeah, we have come to the very conclusion. Here, like, we have to acknowledge, or we have to give acknowledgement to this kind of, let me say, organization. Could be organization, could be in person, but here, yeah, our database, yeah, we got our database on this kind of organization. We collected some of these data sets for the nutrition for elderly people and managing chronic diseases. So we managed to drop some kind of data set from there. So we are so happy to collect also, or to
Hello.
like ESPEN. So that's European Society for Clinical Nutrition and Metabolism. So we also try to get some data that is based on, like, let me say, metabolism, like how food is supposed to be taken into the body and all that. That's the kind of data we got from there. And we are also happy to collect, or we are also happy with this kind of organization that we got some data from there. We also have a food composition table for Central and Eastern Uganda. So here we mainly got data sets that are based on on these regions, that Central and Eastern Uganda. We also do appreciate that. And we have my food 24 Uganda food composition database. So this one we also got some, as in we told you earlier that our data sets, yeah, mostly it is of our own, but we can't fail to appreciate this kind of organization, because we also got some from there and we integrated, and we are able to come up with some kind of data set. So we do really appreciate, and we are very thankful for this kind of work that we got from this organization. So we would like to stop here. Yeah, that's all we have for you. Maybe we shall do best next time when we are trying to present. Of course, this is like kind of part of it. Yeah, we have not fully developed, but that's the start, and we are hoping to do best next time. Thank you.